So good afternoon, everyone. I'm glad that you guys are here and did the warm-up. It looks like we're missing quite a few people today. Not good to see, so I'm glad you guys are here. We're going to take a look at this warm-up to review what we've been working on, and then we're going to spend more time working on more Soh-Cah-Toa problems. So with the Soh-Cah-Toa problems today, we're going to be doing some word problems, practicing drawing pictures, labeling them, and figuring out how to solve them. Okay, as always, if you guys have questions, please just dive right in and ask a question. I'd love to help you guys. Let's go ahead here and first take a look at Soh-Cah-Toa and what does it mean. So the S in So stands for sine of theta, right? Theta is our reference angle, and that equals, and then the next two letters are going to tell what's going to happen. The O stands for opposite, and it comes first, so it's going to be on top. The H stands for hypotenuse, so that's going to go on the bottom. So we got sine of theta equals opposite over hypotenuse. Okay, again, the O is opposite, it comes first, so it goes on top. The C stands for cosine of theta, right? The A stands for adjacent, it comes first, so it's on top. Okay, so again, the A, right, is adjacent, so it starts on top. The H is for hypotenuse, it's on the bottom. The T is for tangent of theta. Oops, I ran out of room. And the O is for opposite, that's on top. The A is for adjacent, that's on bottom. Okay, now, I'm not saying that you guys need to write out this full statement every time we do a trig problem. What I'm saying is that if you guys can relate this to Soh-Cah-Toa, then you don't need to write that out, right? We can just write down Soh-Cah-Toa, and then we can realize, oh, the S is sine, the C is cosine, the T is tangent, the O is opposite, the H is hypotenuse, the A is adjacent, okay? So again, when I'm solving any or all of these problems, I'm going to write down Soh-Cah-Toa to help me figure out, okay, what ratio am I going to use? Okay, and I'm going to model that today as well. Okay, speaking of which, right, going and solving this triangle. So a couple of things to think about. There are two missing sides. Now remember from algebra, hopefully you guys took away that for every unknown, we need an equation. So if we have two unknowns, we're going to need two equations. So what I like to think of this is like two problems in one. So I'm going to go ahead and do one problem first and then do the other one. So I'm going to solve for x first. And to do that, I'm just going to act like, I'm going to act like the y isn't even there. Because that might be easier for some of us to think of this as not as two problems, but just do one problem at a time. So the first thing I'm going to do is I'm going to label. So if I cover up that y, I'm just going to solve for x, okay? We act like the hypotenuse has nothing on it. Now, I don't normally label things that have nothing on them. So this is my reference angle. That means this is the opposite. This would be my hypotenuse. So then that means this is adjacent. Okay. And what this does when I write Soh-Cah-Toa, it really gets me focusing on, okay, this is the side that I want to solve for. It's opposite. And then this is the side that I know, right? This is the given side. So I want to find a ratio that has O and A in it, right? Opposite and adjacent. So that's not sine. It has opposite in it, but we don't want the hypotenuse. Cosine has adjacent in it, but we don't want the hypotenuse. So this is going to be a tangent ratio. So I'm going to write tangent of my reference angle, which is 27 degrees, equals, and then looking at TOA, the opposite comes on top, so that's going to be x, and the adjacent comes on the bottom, right? And that's the new stuff. That's the trig. Being able to use Soh-Cah-Toa and label the triangle so that we can come up with a ratio that we can solve. Okay. And again, if you guys have questions, please jump in at any point. I would love to help. Okay. So that's the geometry part. What comes next is like the algebra part, right? We want to break this down and solve for it. So the x right here is on top. That's what we want, but we don't want this 10 with it. So it's x divided by 10. So the opposite of divide is multiply. Okay, so I'm going to get 10 tangent of 27 degrees equals x. Okay. So there's my exact answer. Okay. So, but we're going to, let's say we round this to the second, or I think the homework has been having you round to the 10th. So we're going to round, well, let's round to the second. Let's do that. We'll do the 10th for our other problems. So if I type this into the calculator, I can go 10 tangent of 27. Oops, and am I in degrees? I was just in a pre-calc class and we were doing radians. So make sure you're in degrees. So I get, so if I round this to the second decimal place, I always look to the decimal place afterwards. And then I say if it's 5 or higher, I round up. Well, it is 5 or higher. So I'm going to round this to 5.10 is approximately x, right? Because 9 plus 1 is 10. All right, does anybody have questions about that? You guys doing okay? I'm a little worried because no one has said anything all class, and so like it makes me wonder, like, are we broadcasting or are you guys just waiting for my sound to work? Okay, so we are alive. Thank you. I got one of the 32 to say something. All right, so now what we're going to do is we're going to solve for the y, so we can cover this up, right? So again, my y now is my hypotenuse, and I know my adjacent. So I'm going to write down Soh-Cah-Toa, and I'm going to look, okay, what uses the hypotenuse and adjacent? So sine is out, right? Because that's opposite. And then cosine. So cosine is adjacent and hypotenuse. So when I set this up, I'm going to say cosine of my reference angle, right? So 27, it equals, and then I have adjacent, so 10 over my hypotenuse. Okay. So, and then once you get this down, right, the trigonometry, it's over. So now it's solving. So now I want to solve for y, so I'm going to use my algebra skills. So in using my algebra skills here, right, I have 10 divided by y, but when I solve for something, I never want it on the bottom. I want it on the top, and I want it by itself. So I'm going to do the opposite of divide. I'm going to multiply. So I get y cosine of 27 degrees equals 10. Well, I still have this cosine of 27 with the y, so it's y times. So the opposite of times is divide. So I'm going to go ahead and divide both sides by cosine of 27. So I get y equals 10 divided by cosine of 27 degrees. Okay, that's my exact answer. So for my approximate answer, I'm going to type this into my calculator. I got 10 divided by cosine of 27 degrees, and I get y is approximately, and if I round to the second decimal, right, this is not 5 or higher, so I'm just going to leave this at 11.22. Okay, and that's what I got for solving this triangle. Okay, and so solving a complete triangle like this is something that you guys are going to do more of the further you go in math, right? Like, you're going to want to get the full picture, not just a partial picture. So does anybody have questions about this? Does anybody want me to go back and re-explain something? Or did I lose someone? Did I go too fast? And I appreciate you guys interacting and using the chat, because it's the only way I know that you guys aren't zombies and you're killing everyone. And I should call, I don't know, who do you call when zombies are killing everybody? Guess I'd call my parents. Tell them I love them one last time. Brains. Right? Maybe I call the pirates and the pirates come and take care of the zombies. Isn't that how it works, right? Pirates versus zombies? Or is it the ninjas? I can't. I always feel like it's harder to get hold of the ninjas, though, if you know what I mean. Right? It's harder to find the ninjas. I would be a pirate, though, right? Because I'm always trying to find X. You know, trying to find me treasure. Well, plants are the long game. Plants win out in the long run. All right, guys. So what are we doing today? Well, we're going to be doing some word problems. So I'm going to go ahead and we're going to start with a combination of word problems. We're going to talk about how to set up pictures, how to set up the trig with word problems. So this first problem is actually something that comes from my life 2 years ago. And so I'm going to share what happened and how I used trig to solve it. Okay. So I have a home and I needed to get up onto my roof because some shingles blew off and I had to replace the shingles, but I didn't have a ladder long enough. Because some of you probably are like, what ladders? So there's two types of ladders. So there's something that's called an A-frame ladder because it looks like this, right? It's often sometimes called a painting ladder because you can put a can of paint at the top, right? And then it has like little steps up like that. Okay, so this is called an A-frame ladder. Here I can even put like a person up there and going like that. Okay, but the kind of ladder that I'm looking for, so an A-frame ladder, to get an A-frame ladders aren't super tall. You can get them tall, but they get really expensive. So what I was looking for was an extension ladder. And the way that an extension ladder is, if you have a wall, you lean the ladder against the wall, right? And then maybe it goes up a little bit higher like this. Okay, that's an extension ladder. Okay, so the kind of ladders that I'm talking about are extension ladders. Okay, does that make sense? Right? Because that could be confusing. If you've never really used ladders, right, you might be thinking of an A-frame ladder. So when I use ladders today, I'm talking about like just a flat ladder that you lean against a wall and you climb up. Okay? Does that make sense, guys? Not an A-frame ladder. Okay, A-frame ladders are really good for painting because you don't want it to lean it against the wall that you're painting. Okay, so we're talking about A-frame ladders. I mean, no, we're talking about like extension ladders. Okay, here we go. Okay, so for extension ladders, I don't know why I capitalized ladders. I'm so sorry. Ladders to be safe, right? Because we wouldn't want to do something that's not safe. Okay. They must be placed at 40 degrees with the ground. Okay, so for extension ladders to be safe, they must be placed at 40 degrees with the ground. Now, if you go to a hardware store and you look at ladders, all modern ladders will come with a safety label that will say, hey, when you set this up, it has to be at this minimum degree with the wall, right? Or else the ladder, if it's too steep, it will slip or it will fall, right? And that's the worst thing. You don't want that, okay? So to be safe, they come with a recommendation for an angle, okay? So, so in my case, so if you want, so in this case it was me, so if you want to get to the top of a roof, right? So in this case it was my roof, right? It'd be weird if you just took a ladder with you and got on other people's roofs. And it's not just weird, that would be illegal, right? That'd be trespassing. So don't be like, well, my math teacher says to go get a ladder and get on people's roofs. If you want to get on the top of a roof, let's say that is 25 feet up. Okay. So if you want to get to the top of a roof that is 25 feet up, how long of a ladder do you need? Now, I don't know if you guys have ever, like, I don't know if you guys hang out in hardware stores, because, like, when I was growing up, like, the cool place to hang out was the mall. So, like, maybe the cool place now is to be like, dude, you want to meet up at Home Depot? Like, I'll meet you in the nuts and bolts section. And you're like, dude, nuts and bolts section, yeah. So maybe that's just a wild guess there. But ladders are expensive. So I wanted to buy the size that I needed because I didn't want to waste money on getting a ladder that was bigger than I needed, right? So I needed a ladder that could get me up 25 feet up. So, like, a lot of you are saying, like, well, just get a 25-foot ladder. Well, if you did that, you're not getting onto your roof, okay? Because 25 feet is straight up and down, and we're going to be angling this guy at 40. Okay? So what I'm going to do is I'm going to have you guys try this out on your own without any help, because this is problem solving. This is what I had to do. So I'm going to give you guys 4 minutes to draw a picture, label the picture, and use trigonometry to figure out how long of a ladder you need. And we're going to round, because your homework tomorrow is going to be, we're going to round our answer to the nearest tenth. Oops, 10. That's the first decimal. Okay. So draw a picture, label it, figure out what trig ratio am I going to use, find the length of the ladder. All right, guys, let's go over this. So we have to draw a picture, right? So the first thing I like to think about is we're trying to get on a roof, right? So I think of a house, like a real basic house, right? Okay. Now, of course, you guys don't have to draw your picture anything like this, right? It could just be a basic triangle, right? So there's no requirements on the picture. So the first thing I'm going to label is, this is a roof. Okay, so I have a roof, and my roof is 25 feet off the ground. Okay. Then I know that I'm going to have a ladder. Right? This is my ladder. And then that ladder is going to be touching the ground. Okay, so notice how to make this image, right? I have made it a complete image, and there should be a right triangle in it, right? There's always going to be a right triangle in it. So if you just drew the right triangle, you'd be totally fine. But the problem says I have a ladder going up to a roof, okay, and it's 25 feet up. Now let's see what else do we know. So it must be placed at a 40-degree angle. Sorry, I'm tilted here. Must be placed at a 40-degree angle with the ground. So it's important we label the ground because it's going to be 40 degrees with the ground, right? So if you didn't label the ground, there's a good chance you could have put the 40 up here. Okay. So now I've got all, so then, and then what are we trying to find? How long is the ladder? So the X, right? The X goes with the ladder. So now I'm going to label everything I have. So I have, here's my 90. So this is my hypotenuse. The side furthest away from my 40 is my opposite. Okay. So I'm going to think Soh-Cah-Toa. What uses opposite and hypotenuse? Well, it's that first one, right? Sine. So I'm going to say sine of 40 degrees equals, and then the opposite comes first, so 25 over x. And I'm just going to hit pause here for a second. Do you guys have any questions about how I drew my picture, how I set it up? Because I'm going to be asking you guys, right? We're going to be doing more of these. So, right? So does anybody have questions about setting up the picture or labeling things? I appreciate feedback. Thank you guys. I need to know if you guys are doing well or if you're stuck, if you're confused. Because if you're stuck or confused, I have lots of things that we can do to get unstuck or unconfused. But if you guys are doing great, then that's great. Okay. So so let's go ahead and solve this then, because I'm not getting anybody telling me they're stuck. So I don't want x on the bottom, so I'm going to multiply both sides by x. So I get x times sine of 40 degrees equals 25. I'm going to divide by sine of 40 degrees. And I'm going to get x equals 25 over sine of 40 degrees. So this is my exact answer. So if I go to type this into my calculator, I'm going to get 25 over sine of 40 degrees. And I get, which is approximately 38 point. Now, if I take a look at the first decimal, that's the tenths, and I go to the right, that is 5 or higher. So I'm going to come back and I'm going to round that here. And then you guys have to ask yourself, did you include units? Units are really important, right? If you go to a hardware store and someone's like, how can I help you? And you're like, well, I'm looking for a 38.9 ladder. And they're going to be like, feet, meters? Well, hopefully they don't say meters unless you go to Canada. Right? So we want 38.9 feet. That is the bare minimum. So whatever I get, I have to get something that is at least this, right? So, and I would probably look at that as saying it has to be at least 39, and you probably want a little bit more, right? Just in case, right? So maybe you're looking at a 40-foot, at least a 40-foot ladder, okay, to get up to the tallest part of your roof. All right, super exciting. Does anybody have questions or comments or anything like that? All right, so the more that how that story ended is I went to the store and I was like, I need this long of a ladder, and was like, oh my gosh, ladders are really expensive. And then they cut off both my legs and took that as payment. And that's why you never see my legs. Now you know. Okay. Well, let's move on. Let's do some more problems. Right? You've never seen my legs. Do they exist? Right? If you don't see them, do they exist? Right? If a tree falls in the wood, Would you know? And so some of you are like, yeah, I've seen your legs before. Well, when's the last time you seen them? Maybe I just recently got a new ladder. Checkmate. All right, so next up, we're going to do another word problem, okay? So this word problem, we're going to take a slightly different approach. So this problem, we are going to be building a new airport in Skagit. Whoop, whoop, whoop. Okay, but this time, we're going to build it out in, like, concrete. Now, you're like, why do you need an airport in concrete? And I say, why not? Okay, people in concrete want to travel too. All right, so we're gonna build a new airport in concrete. I can tell you guys are excited about this. Okay. So, but there's something that we have to make sure. So, taking off from an airport requires planes to be at 35 degrees with the ground. Now, I totally made up that number. Just want to be super clear. But different planes require different takeoff angles, right? So very small planes can almost just go straight up, okay? But bigger planes, right, can't go just straight up. They're going to go at an angle. So let's just say we're going to build an airport that allows, here I am critiquing my own word problem. We're going to build an airport that allows planes to go at 35-degree angles with the ground. That would have been a much better question, okay? But there's this problem with building an airport in concrete, okay? And that is the mountains, right, are 10,000 feet high around the airport. Okay. So if you got 10,000 foot mountains around the airport, and I know concrete's silly, but like think of like places that are surrounded by mountains, like Denver or Mexico City, right? Can we just we're not doing blimps and we're not doing hot air balloons. Okay, so we want airplanes. Okay, so what we're gonna do is we have to figure out. Okay, so if we got these mountains that are 10,000 feet high around us, right? We got to figure out then where can we place this airport so that airplanes taking off don't hit the mountains, because that's not a good thing. That's a bad thing, right? So we're going to ask the question, how far away should the airport be so that planes taking off at 35 degrees with the ground make it over the mountains? Jeez, Craft, I thought this was a math class, not an English class. Sorry, guys. Taking off. Okay, so how far away should the airport be so that a plane taking off at 35 degrees with the ground makes it over the mountains, which are 10,000 feet high? So I'm going to give you guys some time. I want you to try to draw this as a picture. Now, obviously, the picture is not going to be drawn to scale. Try to draw a picture. Remember, it's going to be a right triangle. Right, so it's going to be a right triangle. So try to draw this picture. You're going to have an airplane taking off. Did I make a mistake? I probably did. I'm just gonna. Okay. Anyways, I'll read over it and find my mistakes. So focusing on the math, it should be a right triangle, right? You have an airport. It's gonna take off from the airport, but it's going at 35-degree angle, and it has to go over 10,000 foot, right? So think of a right triangle, right? You have an angle with the ground. You have a height that you have to clear. We're trying to figure out how far away that airport needs to be, minimum, from the base of those mountains. Right, and I agree, right? You want them to clear that height before the mountains, but if you find the exact height, right, then you can say it has to be further than this, right? Because you don't want, and we could make this problem more complicated, right? You could be like, the federal air agency says that you have to clear those mountains by at least 5,000 feet. So you just tack 5,000 feet onto the mountains, and then you'd be good to go. Alrighty then, let's take a look at this. So what I drew is I have like this airport and I have this plane, right? So I got this plane here, maybe it has like a jet engine, and it has like some beefy wings, okay, and like a cockpit. Oh yeah, maybe some windows. Oh yeah, very nice, and it's going very fast. All right, cool. And it's taking off at an angle of 35 degrees with the ground. And we got to be careful of these mountains, right? So how tall are these mountains? Well, these mountains are, maybe I should go like this, 10,000 feet. Okay. Right, so they're 10,000 feet, so we got to get over these mountains. And what we want to know is okay, how far away does this airport have to be from the mountains so that we can be able to clear them, right? So does anybody have questions about my setup? Right, so we got this airplane taking off. We want to know the distance from the airport to the base of the mountains, and the mountains are 10,000 feet high. Anybody have questions about that? Do you guys see the right triangle there? Yeah, 10 out of 10 would fly again. Okay, but maybe it was a 9 out of 10 because maybe the in-flight service was pretty bad. Okay, so I'm gonna label. So across from the 90 is the hypotenuse, but there's nothing here, and like we don't really care about the flight of the airplane. Now, some really cool things that you could do with this, the flight of the airplane could be really cool if you were talking about how much gas we're gonna use, right? But because then you'd have to know the distance traveled, so that would be really important. So lots of different cool things we could do with that. But what I want to know is, this is my opposite, this is my adjacent. Okay, so when I write down Soh-Cah-Toa, I'm going to be looking for opposite and adjacent. So this has opposite but not adjacent. This has adjacent but not opposite. So I'm going to be using tangent. So I say, okay, tangent of 35 degrees equals, opposite comes first, so that's 10,000 over the distance to the mountains. Okay, and I'm going to hit pause there for just a second and see if you guys have any questions, and then I'll continue to go on and solve this. Okay. I always feel like I should have a cool name like Detective Krept because I solve math mysteries. Yeah. You know what I mean? Like, what's up with that? Why do cops get the cool names? I want a cool name too. Detective sounds cool. So what if I multiply both sides by x like this? The x's go away. I get x tangent of 35 degrees equals 10,000. Okay. But I don't want the tangent here, so I'm going to divide by tangent of 35 degrees. And so that is my exact answer. Okay, now again, units are going to be really important here. So if I round this, I'm going to round this. Let's do this, the second decimal. I didn't say which decimal to do, did I? I'm a terrible person. Now let's see here, tangent of 35, and I get x is approximately 14,281.48. Now that's in feet. So if you convert that to miles, I think that's about 2.7 miles. Okay. So what we're saying, right, is that if we're going to build this airport in concrete, we just have to make sure that the airport is 2.7 miles from the base of any mountain, so that our airplanes can quickly and easily and safely get over those mountains. Okay, all right, kind of cool, kind of cool. Yeah, you know, it's not summer yet, so it's not too hot, but it's kind of cool. All right, we're gonna finish up class with one that we kind of did last time, but we ran out a little bit of time, and I want to see if you guys can do it on your own. And that is going to be a height problem. Okay, so here is one that I want you guys to try. So this one has to do with Jose. So Jose is looking at a building. Okay, super great sentence there. It feels like really important, right? Looking at a building. Okay, who doesn't, right? Okay, from the ground to Jose's eyes is 5 feet. Okay, so he's not 5 feet tall. It's 5 feet from the ground to his eyes. Okay. And then Jose, sorry, I might be going too fast. Jose is looking at a building. From the ground to Jose's eyes is 5 feet. Okay. So Jose tilts, I should say is tilting his head up 15 degrees to see the top of the building. Building. There we go. Sorry about the building. So Jose is tilting his head up, right? So that would be like if you lift your jaw up, right? You're going to look up. So you're tilting your head up 15 degrees to see the top of the building. Okay. So Jose is tilting his head up 15 degrees to see the top of the building. If Jose is 50 feet away from the building, how tall is the building? Okay, so I'm going to give you guys time to set up a picture and solve for the height of the building. Could be an outhouse, could be a government building, could be a shed, could be Dracula's coffin. I guess that's not a building. All right, guys. I'm gonna, because of the timing, I'm gonna get going right now to make sure that the people that are at school are gonna get going. So I got Jose here. Okay, I know the height to his eyes from the ground is 5 feet. I have a building, and I don't know how tall that building is. Okay, now the thing is, Jose is looking at the building, so he's looking at it from his eyes, and he looks up at 15 degrees. So we have to remember that I should call this h, right? So this total height is h, but if we call this small one x, this is 5 feet. So h of the building is going to be x plus 5 feet. And I'm sure quite a few people forgot to add the 5 feet into their answer, okay? Because he's going to be 50 feet away. Okay, so if I go ahead to do this, this is going to be the hypotenuse, this is opposite, this is adjacent, Soh-Cah-Toa, so that's opposite adjacent, that's tangent. So I would have tangent of 15 degrees equals opposite over adjacent. If I multiply by 50, I get 50, oops, am I on here? 50 tangent of 15 degrees equals x. Okay, and just remember, my h is going to be that, so I'm just going to do this all at once. H equals 50 tangent of 15 degrees plus 5. So I'm just going to go like this. I'm going to go, hey, in my calculator, I'm going to go 50 tangent of 15 degrees plus 5, and I get that the building is, the height of the building is about 18.40 feet. So the building's about 18.4 feet. So does anybody have questions about how I did that? What I did there? Right? I have a feeling that some people forgot to, yeah, get it. I have a feeling that some people forgot to add in the 5, right? That's a very common mistake. That's why I did this problem, right? So does anybody have questions about that? Yeah, and hey, if the only thing you forgot is the 5, then you did really well, right? Like, let's just be real. But just remember, right, when you're doing something from the eyes, you have to adjust. And that's actually a very common problem on the SAT or equivalent test. So that's why I like to do that one, because that does show up on college prep tests. So just remember, guys, tomorrow I will see you guys, and we will be working on some word problems in class for your assignment. So take care, everyone. Enjoy the rest of your day. I will see you guys tomorrow. And if you have questions, come to my office hours tomorrow from 8:30 to 10. Bye, guys.